All right, here we go. Integration by parts. That's the formula that you'll be given in the exam, okay? And there's just a couple of things that you have to be aware of. But on the main, this is just substituting and rearranging in algebra with a bit of integration in there. So it could not be very tricky, it could get very confusing. Now the formula, basically, we use integration by parts when we are trying to integrate the product of two functions, okay? But maybe substitution doesn't work. So in the formula, we're trying to integrate u, which is a function of x, and dv over dx is actually another function of x, but just for our integration purposes, instead of writing v, we write dv over dx because we're going to consider that that function is the derivative of another function. That's why we write dv over dx. And then, so we've got one function multiplied by another function relative to x, and when we integrate, it's going to be the product of the two functions minus the integral of v du over dx, and we're going to have to integrate this bit here. Okay, all right, so let's go through a couple of examples. They asked me to integrate x cos x dx. Now, whenever I got a product of functions like this, and I've got a trig function in there, my u is going to be the x term, the polynomial of x, or the power of x, or the x squared, or the x cubed, or whatever it is, and my dv over dx is going to be the trig function. All right? Or if I got an e to the x, that is also going to be my dv over dx. That's kind of the general rule, okay? That's what you need to be aware of. Whenever you got that kind of function, your x will be your u term, and your trig function or your exponential function will be your dv over dx. So we're going to do some working out here because I need to figure out all these things. So my u is going to be my x, and then my dv over dx is going to be my cos x. Now I'm going to need to integrate du over dx. Well, that's easy enough, because from there du over dx is 1, and I'm going to need my v function. I got dv over dx is cos x, therefore the v function is going to be sin x, which is the integral of cos x, isn't it? If that's dv over dx, v must be sin x. And I think I've got all I need, so that's going to be uv, so u is x, v is sin x, so I've got x sin x minus the integral of v, well, v is sin x, du over dx, which happens to be 1, so that's nice, dx. Therefore, I have to integrate this bit. I've got x sin x. The integral of sin x is minus cos x. So I get plus cos x plus c. And that is a first example on integrating by parts. Let's do a couple more. All right, let's do a couple more and see how it goes. All right, here we go. This is the second example. I gotta integrate x squared log x dx. Now, whenever you've got a log x in there, that is going to be your u, because we don't know how to integrate log x. So if I make dv over dx log x, in order to find v, I have to integrate. I don't know how to integrate log x, so that's not going to work. So whenever I got a log in there, my u is going to be log x, and then dv over dx is going to be x squared. And we'll do like before, we take it from there. I need to find du over dx, which is going to be 1 over x. And to find v, I've got to integrate this, simple enough, x cubed over 3. Now I have got all the moving parts. Good joke there, right? Integration by parts, moving parts. So I can integrate now. So using the formula uv, where u is log x and v is that, so I'm going to write x cubed over 3 log x minus the integral of v, which is x cubed over 3 du over dx is 1 over x dx. So x cubed over 3 log x, I can bring the 3 out, 1/3 of the x cubed of x squared dx. And we're there now, x cubed over 3 log x minus x cubed over 9 plus c. And hopefully that makes sense and that's clear enough. But let's do one more example, because sometimes you may have to integrate by parts twice within the same question, so isn't that fun? Okay, third and I think final example for now, maybe integration by parts. I've got to integrate x squared e to the x dx. So I've got a product of functions. One of them is an exponential, one of them is a power of x. So if you remember the recommendation, u is going to be my x squared, and then dv over dx is going to be e to the x. I find du over dx, which is 2x, and I find v, so the integral of e to the x is enough, e to the x. So now apply the formula. So the integral of that is going to be uv, so x squared e to the x minus the integral of v, which is e to the x. Du over dx is 2x dx, which is going to be x squared e to the x minus 2 times the integral of x e to the x dx. And you can see that here I've got something similar to what I had there. I still got that integral to do, which is a product of functions. So we're going to have to do it again. You need to recognize that you're going to have to do it again. Same story as before. U is going to be my power of x, dv over dx is going to be the exponential. So do again. U is x, dv over dx is e to the x, which means that du over dx is 1, which is quite nice, and v is still e to the x. Apply the formula again. So I've got x squared e to the x minus 2 times, apply the formula again, uv, so x e to the x minus the integral of v, which is e to the x, du of dx, which is 1 dx. So now I've got x squared e to the x minus 2x e to the x. The integral of e to the x is e to the x, so minus times a minus is a plus 2 e to the x plus c. I suppose I could factorize or something like that, but it doesn't really matter. With there, that is the answer. Fun, isn't it?